Hello, little learners. We are happy to have you join us on this exciting journey into the world of computers with Binary Brains, the language of computers. Grade 5, Lesson 6. In this lesson, we are going to learn about what is an algorithm, key points of an algorithm, sequencing, loops, conditional statements. Let's begin with what is an algorithm. An algorithm is a step-by-step set of instructions or rules designed to perform a specific task or solve a particular problem. You can think of it as following: a recipe while cooking, where each step leads to the final dish. The key features of algorithms are clear steps. An algorithm should have clearly defined steps. Each step must be understandable and executable. Input and output. Algorithms take some input data and produce an output result after processing that input through a defined steps. Finiteness. Algorithms must always finish after a certain number of steps. They should not run forever. Effectiveness. The steps of an algorithm must be basic enough that they can be performed in principle with a pencil and paper. Key points of an algorithm. Input. The initial information or data you start with. For example, the ingredients you have for making chapati like wheat flour, water and salt. Processing. The series of steps or actions taken to solve the problem. For example, mixing the wheat flour with water and salt, kneading the dough, rolling it into round shapes and cooking it on hot pan. Output. The final result or outcome after processing the input. For example, soft and perfectly cooked chapatis ready to eat. Decision making. Making choices based on specific conditions or criteria. For example, deciding whether to add more water or flour to the dough if it feels too dry or sticky. Looping. Repeating certain steps until a particular condition is met. For example, rolling and cooking each chapati one after another until enough chapatis are made for everyone. Termination. The point where the process completes its task and stops. For example, the process ends when all chapatis are cooked as required and decided. For example, algorithm for making a fruit salad. Step 1. Start. Step 2. Gather different fruits, for example, apples, bananas, grapes. Step 3. Wash the fruits thoroughly. Step 4. Cut the fruits into small pieces. Step 5. Mix the fruit pieces in a bowl. Step 6. Add a little honey for flavor. Step 7. Serve the fruit salad in a bowl. Step 8. End. Now let us look at another example. Algorithm to find the sum and product of three numbers. Step 1. Start. Step 2. Read, input the three numbers as A, B and C from the user. Step 3. Find sum is equal to A plus B plus C. Step 4. Find product is equal to A into B into C. Step 5. Print the sum. Step 6. Print the product. Step 7. End. Sequencing. Sequencing is the process of arranging steps or instructions in a specific order to solve a problem or complete a task. It's like following a recipe where each step must be done in the right order to get the desired result. Sequencing is the specific order in which instructions are performed in an algorithm. Why is sequencing important? Order matters. In problem solving, following the right order of steps helps you get the correct answer without any confusion. Just like you can't put your shoes on before putting on your socks, the order of steps is important. Clarity. Sequencing helps make the instructions clear and easy to follow. Efficiency. It ensures that the task is completed in the most efficient way possible. For example, order. Choose your food item and place the order. Pay. Make the payment using your preferred method. Collect. Pick your order once it's ready. If you don't follow the sequence of order, pay, collect, here's what could happen. If you try to collect before ordering, you won't get the order because you haven't told the staff what you want. If you collect before paying, the staff won't let you take the order because you haven't paid for it yet. If you pay before ordering, they won't know what to charge you for because you didn't tell them your order. So the steps must be in order to ensure everything runs smoothly. Loops. A loop is like a repeat button for instructions. Imagine you have a list of things to do and you want the computer to do them over and over again. You use a loop to tell the computer, keep doing this until I say stop. In this chapter, we will study about two types of loops, for loop, while loop. Let us know what is for loop. For loop is used when you know exactly how many times you want to repeat something. You set the number of repetitions ahead of time. We will go through the steps for loop algorithm, printing numbers from 1 to 10. Step 1. Start. Step 2. Initialize a variable I and set it to 1. This will be the number we start with. 3. Check if I is less than or equal to 10. If yes, continue to the next step. If no, stop the loop. End. 4. Print the current value of I. 5. Increase the value of I by 1. Now I is equal to I plus 1. 6. Go back to step 3 and check if I is still less than or equal to 10. 7. Repeat steps 4, 5 and 6 until I is greater than 10. 8. Stop when I is greater than 10. Explanation of how it works. I is equal to 1, print 1, then increase I to 2. I is equal to 2, print 2, then increase I to 3. I is equal to 3, print 3, then increase I to 4. This goes on till I is equal to 10, print 10, then increase I to 11. I is equal to 11, stop, because I is no longer less than or equal to 10. Now let us learn about while loop. While loop is used when you don't know how many times you need to repeat something, but you keep repeating it as long as a certain condition is true. The loop keeps going until the condition is no longer true. We will go through the steps for while loop algorithm, taking user input until quit. Step 1. Start. Step 2. Initialize a variable user input. Step 3. Repeat the following steps as long as the user input is not equal to quit. Ask the user to enter some input. For example, please enter something. Store the user's input in the variable user input. Check if user input is equal to quit. If no, go back to asking the user for input. If yes, stop the loop and end the process. Step 4. Stop when the user enters quit. Explanation of how it works. The program starts and asks the user, please enter something. The user types hello and presses enter. The input hello is stored in user input. The program checks if the input is quit. If no, the loop repeats and asks for input again. 3. The user types quit and presses enter. The input quit is stored in user input. The program checks if the input is quit. If yes, the loop stops. Conditional statements. Conditional statements are like rules that help us make decisions based on certain situations. They tell the computer to do something only if a specific condition is true. You think of them as if-then statements. The conditional statements are important because decision making. They help the computer make choices based on different situations. Flexibility. Conditional statements allows programs to respond differently depending on what's happening. Conditional statements can be categorized into several types based on how they work. The main types of conditional statements are if statement, if else statement, if else if. If statement. An if statement checks whether a condition is true. If it's true, the code inside the if block runs. If it's false, the program skips the code. For example, if it's sunny, then play outside. You check if it's sunny. If it's true, yes, it's sunny, then you go outside and play. If else statement. Now, let's make the previous example a bit more fun with two options. For example, if it's sunny, play outside. Else, play a board game indoors. You check if it's sunny. If true, yes, it's sunny, then you play outside. If false, no, it's not sunny. Else, you play a board game indoors. If else if, multiple conditions. Now, let's add more choices to our example. For example, if it's sunny, play outside. Else, if it's raining, read a book. Else, if it's windy, fly a kite. Else, watch TV. You check conditions in order. If true, it's sunny, then play outside. If the first condition is false, but the second condition is true, it's raining, then read a book. If both are false, but the third condition is true, it's windy, then fly a kite. If all conditions are false, else watch TV. Computers use conditional statements to evaluate conditions and decide which instructions to execute. For this, we write programs in various programming languages like Python, Java, or C++. Let's explore some more examples of how Python implements these conditional statements. If statement. To check if a number is smaller than another number and display the result. Here, x is equal to 5 and y is equal to 10. These lines set values of x and y. The program knows that x is 5 and y is 10. If x is less than y, this line checks if the value of x, that is 5, is smaller than value of y, that is 10. Print x is smaller than y. This line specifies the action to be taken if the if condition, that is x is less than y, is true. Let us run the code to see the output. Since 5 is less than 10, the if condition is true. The program prints x is smaller than y. If else statement. To check if a number is positive or negative and display the result. Here, number is equal to -3. This sets the value of number to -3. If number is greater than or equal to 0, this line checks if the value of number is greater than or equal to 0. Print number is positive. This line specifies the action to be taken if the if condition is true. Else print number is negative. This line specifies the action to be taken if the if condition is false. Let us run the code to see the output. Since -3 is greater than or equal to 0, condition is false. The program skips the line print number is positive and runs the else block print number is negative. If-else if statement. Classify a number as positive and even, positive and odd, negative or 0 and display the result. Here, number is equal to 10. This sets the value of number to 10. If number is greater than 0 and number %2 double equal to 0, this line checks if the number is greater than 0, positive, and divisible by 2, even. Print number is positive and even. This line specifies the action to be taken if the condition is true. Similarly, the other elif lines are other conditional statements the program is required to check. The else line is the conditional statement if all if and elif statements are false. The print lines mention actions to be taken for each conditional statement. Let us run the code to see the output. Since 10 is greater than 0 is true and 10 modulus 2 is equal to 0, I is also true. The if condition becomes true and the output is print number is positive and even. The program does not check the other conditional statement elif because the first condition was true. Note: you will learn about these concepts in more detail in further grades, where we will explore how these programming languages work on computers. We will also dive deeper into writing and understanding such codes. That's all for today, students. Hope you had fun learning about algorithmic thinking. Want to test your brain? You can attend a quiz of this chapter on Dattam's website. Once you finish attending the quiz of all the chapters, you will receive a certificate. Scan the first QR code to visit Dattam's website or click on the link provided in the description box. Scan the second QR code to learn how to navigate to assessment page and access the quiz section on the website, or click on the link provided in the description box. You can also download this PPT from the Tamsh website. Great job, little genius! You have finished lesson 6. Don't forget to like, share and subscribe. See you in the next lesson. Happy learning!